So this video is going to be our second technique for solving differential equations. It's 9.5 and it's all about linear equations. So let's talk about what a linear equation is. A first order linear differential equation is a differential equation that can be written in the following form. dy dx plus p of x times y is equal to q of x. Okay. This is actually called, not only is this the form of a linear differential equation, but we have a name for this, guys. This is called the standard form of a first order linear differential equation. Okay, standard form. Some characteristics we notice. We notice that the dy dx and the y, the reason this is called linear is because the dy dx and the y are both to the first power, right? We notice that this is to the first power, this is to the first power, okay? Now, p of x and q of x are not necessarily linear, so note, let me just say that p of x and q of x can be any functions. Okay, what I mean is they are not necessarily linear. Okay. Now, it turns out that we have an exact method for how to solve these types of differential equations. Solving a first order linear differential equation involves finding an integrating factor. Now, we don't quite know what this means yet. An integrating factor is a term that makes integration easier. The idea is that when you multiply a first order linear differential equation by an integrating factor, you end up with a differential equation that integrates really easily in a particular form every single time. So what I'm going to do now is an example. This is going to be a demonstration of the integrating factor method. So this is going to be demonstration. What's going to happen is I'm going to do this problem, and as I do the problem, we're going to be going over some steps, and then after these steps, I'm going to write out the general method for how you solve such a differential equation. So we're going to solve the following differential equation. This is our differential equation, and we are also given the following. I of x is equal to x. And this is the integrating factor. integrating factor. We don't know what this means yet or where it even comes from. For now, it's going to be given, but I will show you guys how to actually find the integrating factor yourself. But let's go through this process one time first, just so you guys know what to do with it. Okay, so here's the first step. The first step is to multiply the entire equation by the integrating factor. So we're going to multiply everything by x. So let's see what we get. So this is what we get. And now from here, we're wondering how we're going to solve this differential equation. Here's the idea. The idea is to notice something. We notice that the left side here is actually a particular derivative as given by the product rule. In fact, it is the derivative of xy. Let's see if that's actually true. Remember, the way you differentiate this using the product rule, it would be the first times the derivative of the second, that's x times dy dx, which you see above, plus the derivative of the first, which is 1 times the second. So hopefully you guys see that the derivative of this is given above by implicit differentiation. So this is what we get. Now what? Now the trick, once we write it like this, this means that this is actually separable. In fact, we have this. Now, it's not what we would normally see. Normally we have a dy and we have a dx. But the idea is that once you separate, you can just take the integral of both sides. And the left side, the integral of d of xy is just xy. So we get xy is equal to, and then we get an x squared plus c. So this is how we would write our answer. Or if we divide everything by x, we get y is equal to x plus c over x. That's another way of writing our answer. So this idea of using the product rule in reverse and the integrating factor technique, it always works, but what we need to do now is figure out where the integrating factor comes from. So let's go ahead now and derive the integrating factor. So integrating factor formula derivation. Okay, so we're going to start with a first order linear differential equation. So we're starting with a first order linear. It looks like this. dy dx plus p of x times y is equal to q of x. The trick here is to suppose we have an integrating factor. So suppose I of x is equal to the integrating factor. We're going to pretend that I of x is an integrating factor and find out what it would have to be to make the previous method that we just did work, okay? So what we're going to do, let me go ahead and we're going to call this guy star. So what I'm going to do is I'm going to multiply the equation star by I of x. And so now what we end up with is I of x times dy dx plus I of x p of x y is equal to I of x times q of x. Now what we want to do is we want this guy, we want that to equal the derivative of I of x times y. Because if we go back to the previous problem, you notice here, that's exactly what happened here. We had this guy, your I of x is right here, and then you just had a y. Okay? We want the exact same thing to happen. We want the integrating factor times the y to be the result there. Okay? So we want this to be true. So the trick then is to actually take the derivative of this guy and figure out what we get and set it equal to that. So what is the derivative of this? Well, using the product rule, we get it's the first times the derivative of the second plus the derivative of the first times the second. So in other words, we're going to take this and set it equal to this and then try to figure out what I would have to be. Well, if you set those two equal to each other, let's do this on the next page so that we don't run out of space here. We have I of x times dy dx plus I of x times p of x times y is equal to, so what was the other side? I of x dy dx plus, I believe on the other side we had, let me see, plus I prime of x times, plus I prime of x if we look back here, times y. So this cancels from both sides of the equation. And then what? The y goes away as well because we can divide both sides by y, so that's gone. And it's gone here. And if we actually look at what we have I of x times p of x is equal to I prime of x, which is the same as di dx. Okay, what does this mean? This is actually separable, right? Because I can write it this way. This means that I can write it as p of x dx is equal to I of x di. And then I can integrate both sides. Oh, sorry, I wrote this wrong. It would be di over I. Let me back up a second here. Let me not mess this up. It would be di over I. So if I were to integrate both sides here, here's what I get. I get the integral of p of x dx is equal to the natural log of I. If I take e to the power of both sides, this means that I of x is actually equal to e to the integral of p of x dx. And so what we have just done is we've derived the formula for the integrating factor. Okay? This is the formula for the integrating factor. Okay, so that fills out the missing piece here. Now, notice also I ignored the absolute value, and I also ignored the plus c that you get. That's because we only need one integrating factor. So even though you could use a negative sign and this would still work, you could also add a constant to this. It's not necessary. Okay? So this is our integrating factor. So let me go ahead and write out a step-by-step approach of how to solve a linear differential equation. So steps for solving a first order linear differential equation. So step one, the first thing you're always going to do is to put the differential equation in standard form. This is important. Sometimes your problem does not begin in standard form, so you have to put it in that form. Remember, standard form is dy dx plus p of x times y is equal to q of x. Step 2, find the integrating factor. Okay, the way that you find the integrating factor, remember we wrote down our formula. You're going to do e to the power of the integral of p of x dx. Okay, so you need to take the integral and then do e to the power of that. Step 3. Let me call this standard differential equation star. Step 3 is going to be to multiply both sides of star by your integrating factor. Finally, step 4, here's what you're going to have. You're going to have this. From here, you're going to realize that the left will always be the derivative of I of x times y, and you move the dx to this side and you integrate both sides. So the very last thing is to write your answer. I of x times y is going to equal whatever that integral is on the right. And just to remind you guys, you always have to put the plus c after doing the integral. Okay? So this is the process. It's a 5-step process. And if you forget to do the first step, putting the differential equation in standard form, that's going to be a big mistake, because then that means everything that comes after is not correct. Okay? All right, so now that we have the whole step-by-step process laid out, let's go ahead and do a couple of examples. So this will, starting with now we're on number 2. So we want to solve the following differential equation. dy dx plus 3x squared y is equal to 6x squared. So this is already in standard form. So we just have to identify the p of x. This is p of x. P of x is whatever function is being multiplied by y. So let's go ahead and find our integrating factor. Remember, we are going to have to do the antiderivative of p of x. So the antiderivative of p of x dx, and then we're going to do e to the power of that. So what is the integral of 3x squared dx? This is going to equal x cubed. Next, I of x is going to equal e to the power of x cubed. This is our integrating factor. Okay, so that was step 2. Again, we skipped step 1 because it was already in standard form. So step 3, multiply the entire thing by e to the x cubed. So we end up with the following: e to the x cubed times dy dx plus 3x squared e to the x cubed y is equal to 6x squared e to the x cubed. What do we do here? Remember, the left will always be the integrating factor times y. So this should be e to the x cubed times y. Sorry, the derivative of that. Now, is that actually true? I'm not always going to do this, but I would recommend always checking to see if this is actually true. The derivative of this guy is equal to the first times the derivative of the second plus the derivative of the first times the second. And you'll notice that's exactly what we have up here. This matches this. So that's good. What do we get on the right here? We get that this is 6x squared e to the x cubed dx. And so I'm going to take the integral of both sides. So what do we get on the left? On the left, we just get e to the x cubed y. What do we get on the right? So let me go ahead and do this integral. So I'm going to do this integral over here. I'm going to do this using a u substitution. I'm going to let u equal x cubed. Why? Because its derivative is something with an x squared in it, which appears over there. So if I let du be 3x squared dx, this means that 1/3 du is equal to x squared dx. So we end up with an integral here. This new integral, after I take out the 1/3, it's 2e to the u du, which is 2e to the u. So replace u back, it's 2e to the x cubed. So coming back over here, our answer is like this. This is our solution to our differential equation. Or you can actually write this in terms of solve for y. How do I solve for y? Well, if I divide everything by e to the x cubed, I get as follows: 2 plus c e to the negative x cubed. This is another way of writing the answer. Both of these ways are correct. Okay, so that was our second example. Let's go ahead and do a few more. This time I want to do an initial value problem. This is number 3. I'm going to, actually, let me not do an initial value problem. I want to do a different problem. Let me solve the following. It's going to be dy dx equals x e to the negative sine x minus y cosine x. Now, I want us to notice that this is not in standard form. Not in standard form. How do we get it in standard form? We have to begin by moving this guy to the other side. So if we do that, we get as follows: dy dx plus cosine of x times y is equal to x e to the negative sine x. Now it's in standard form. So our p of x is right here. So let's go ahead and find our integrating factor. Let's start by integrating that. What's the integral of cosine of x? This is equal to sine of x. And so then I of x is equal to e to the integral of cosine x dx, which is going to be e to the power of sine of x. So this is our integrating factor. So I'm going to multiply the whole thing by e to the sine x. Notice when you multiply the right side by e to the sine x, you just get x. Because e to the sine x times e to the negative sine x just gives you a 1. From here, what comes next? The left side is really the derivative of, remember it's always I of x times y. So this is going to be the derivative of e to the sine x times y. And we have an x dx over here. Now I would check this if I were you, that the derivative of e to the sine x times y really is what we get up there. And if you check it, you'll see that it is true. And so here you integrate both sides. So on the left we get e to the sine x times y, and this is equal to 1/2 x squared and then plus c. We can leave our answer like this, or we can write it a different way. If we multiply both sides by e to the negative sine x, we get as follows. Y is equal to 1/2 x squared e to the negative sine x plus c e to the negative sine x. This is another way of writing the answer. Both are correct. Okay, let's do one more example. We'll start it over here. Okay, so we're going to solve the following differential equation. It's going to be x to the 8th y prime equals negative 2x to the 9th y plus x to the 9th. Okay, now this is definitely not in standard form. But if we recall, standard form looks as follows. So what we need to do is we need to get everything with a y in it on the left first. So I'm going to add 2x to the 9th y to both sides, plus 2x to the 9th y. So if we do that, on the left side we have x to the 8th y prime plus 2x to the 9th y is equal to x to the 9th. Now it still doesn't quite look like the standard form because we need to get dy dx by itself. Dy dx is not by itself right now because it's being multiplied by x to the 8th. So we're going to divide the entire equation by x to the 8th. This leads us to the following. Y prime, which I'm going to write it as dy dx just so it's more familiar. Dy dx plus 2xy is equal to x. Now we're in standard form. So all of that was just step 1. Step 2, let's go ahead and find I of x. So I of x is equal to, remember this is p of x, right? This is p of x. Okay, so it's going to be e to the integral of 2x dx, which is equal to e to the x squared, right? Because the integral of 2x is just x squared. Okay. All right, so now if I were to call this star, we multiply star by e to the x squared. So we end up with e to the x squared dy dx plus 2x e to the x squared y is equal to x e to the x squared. And you'll notice that the left side is the derivative of e to the x squared y. And so we integrate both sides. What does the integral of the right side become? Let me do this on the next page just so we have it. Integral of x e to the x squared. This is a u substitution. I'm going to let u equal x squared, so that means du is equal to 2x dx, or 1/2 du is equal to x dx. So this becomes 1/2 e to the u du, which is equal to 1/2 e to the u after you take the antiderivative, plus c, which is equal to 1/2 e to the x squared plus c. So coming back to the other page, the integral of the left is just e to the x squared y, and the right we get 1/2 e to the x squared plus c. So this is how we write our answer. Or if we want to divide everything by e to the x squared, we can, and we end up with y equals 1/2 plus c e to the negative x squared. Two ways of writing the answer. Okay, before we conclude this video, I want to give you guys one last thing to look out for, okay? So, tip, be careful if p of x y term is negative, the minus is part of p of x and must not be ignored. What do I mean by this? Well, let's say you had something like this. It is extremely important that you include the entire minus 3x in your p of x. Your p of x is negative, and that negative will make a difference, right? Because if you do the integral of negative 3x squared dx, this is going to be negative x cubed, and then when you take e to that power, it becomes e to the negative x cubed, which is very different from e to the positive x cubed. So the point is, do not leave your negative signs out when you're figuring out your integrating factor, or it will mess up everything. Okay, thank you so much for watching this video. See you next time.